Hi friends, in this video, find a diagonal matrix orthogonally similar to the real symmetric matrix. So means we have to find this diagonal matrix D, which is orthogonally similar to this real symmetric matrix A. So what I mean by this D matrix is orthogonally similar to A. So there exists a orthogonal matrix P. So there exists a orthogonal matrix P such that since P is orthogonal, P into P transpose which is equal to I. So therefore, since P is orthogonal, so there exists orthogonal matrix P such that D can be written as P inverse AP. So here P inverse is from here P transpose is same as P inverse. Since P is orthogonal, so you can write D equal to P transpose AP. So here we have to find this diagonal matrix with the help of model matrix P and P transpose, and this is a matrix which is given, which is real symmetric matrix. So here the element of this P matrix, that is this P matrix is formed by the eigenvectors of this matrix A. So here this is the matrix of order 3 cross 3. So here we will get eigenvector lambda 1, lambda 2 and lambda 3 corresponding to find each eigenvalue, find the eigenvector x1, x2 and x3. So here in the P matrix, that is your P matrix, here first column is the first eigenvector, second column is the second eigenvector and third column is the third eigenvector, but that should be normalized and mutually orthogonal. Means here x1, norm of x1 is 1, so norm of x1 is same as norm of x2 is same as norm of x3 which is equal to 1, and this x1, x2, x3 are mutually perpendicular. Means that is product between x1 and x2 transpose 0, and here and x2 and x3 transpose is 0, and x1 and x3 transpose must be 0. Means these three vectors x1, x2, x3 are mutually orthogonal. So that's what we have to found by using this matrix A. So here how to find the matrix D which is orthogonally similar to this real symmetric matrix is the following. Now, so in the working rule of diagonalizable matrix, first rule is find the eigenvalues of the given matrix. So first rule is find the eigenvalues of the given matrix here, and second rule is find the eigenvector corresponding to each eigenvalue x1, x2 and so on. Third rule is form the matrix P. So having formed the matrix P, that is model matrix having normalized eigenvector which is mutually orthogonal to each other, that is x1, x2. Means in the matrix P, first column is the first eigenvector, second column is the second eigenvector and so on. And third is, so here fourth is D equal to, so P inverse AP. Since P is mutually here P is orthogonally similar, means P is the orthogonal matrix which is existed. So you can write since P into P transpose is equal to I. P is orthogonal, so P transpose is equal to P inverse. Therefore D can be written as P transpose AP. That's what we have to find. So here this is the model matrix, A is the given matrix, and after performing this matrix multiplication, you will get the diagonal matrix having here lambda 1 0, that is up to here. This is 0, second along the diagonal eigenvalue and so on lambda n. So here you will get 0 0 0 here. Means you will get the diagonal matrix with diagonal integer eigenvalues of your matrix A. So that is your aim. That is you have to find the D which is diagonal matrix having all the non-diagonal elements are 0 and diagonal entries are the eigenvalues of this matrix A. So that's we have to find. So here I will find one by one. First I will find the eigenvalue, after that eigenvector, after that I will build the model matrix and D. So here, so how to find the eigenvalue of this matrix? By using characteristics equation. That is the characteristics equation of this matrix is here the characteristics equation I will write. The characteristics equation is determinant of A minus lambda I which is equal to 0. So which is same as I will write. So after expanding this, you will get lambda cube minus s1 lambda square plus s2 lambda minus s3 which is equal to 0. Here what is meant by s1? Here s1 means just trace of this matrix. So what is meant by trace? Sum of the principal diagonal. Along sum of the principal diagonal is a11 plus a22 plus a33 position. That is here 6 plus 3 plus 3 which is equal to 12. That is my trace. Now how to find s2? So s2 means sum of the principal minors along the diagonal. That is here find minor m11 plus m22 plus m33. That is sum of the minors along the principal diagonal. So this is the principal diagonal position of this matrix. Here m11 find the minor of this m22 plus find the minor of this m33. So how to find the minor of this m11 position? Here I want to find the minor of this position. Hide the first row, first column, take the determinant of remaining. Here hide the first row and first column, take the determinant of remaining. That is determinant of 3 minus 1 3. Now we have to find the minor of this element. I want to find the minor of this element means hide the second row and second column. So hide the second column and second row, take the determinant of remaining. So here 6, here 2, this is 2 and 3. Now I want to find the minor of this element, that is minor of this this element, that is m33 position. Hide the third row, third column, take the determinant of remaining, that is 6 minus 2, 6 minus 2, that is minus 2 and 3. So count the determinant, that is 9 minus 1 plus 18 minus 4 plus this is 18 minus 4 here, which is equal to 8 plus. So here this is 14. So this is 14. So this is equal to 36. This is my S2. Now find the value of S3. So S3 means just the determinant of this matrix. Here I will find S3. So here S3 equal to determinant of this matrix, that is determinant of this matrix 6 into, here I will find here only. So write S3 equal to determinant of this matrix which is equal to here 6 into here 9 minus 1, 9 minus 1 minus this is plus 2 into here minus 6 plus 2, this is minus 6 here minus 6, this is minus plus 2 and last plus 2 times here, this is 2 times 2 minus 6, that is 2 minus 6 which is equal to, I will write here. So here after that again I will write in short form. Therefore S3 equal to here 6 into 8 plus 2 times, this is minus 4, so plus 2 times this is minus 4 which is equal to here 48 minus 8 minus 8. So here start solving from this side. So 48 minus 8, this is 40 minus 8. So 40 minus 8, this is 32. This is my determinant S3. Now here in short I will write. So you will get S1 as 12, S2 is your 36 and S3 is my 32. So here I will write S1, S2, S3. So here S2 I will directly write my S2 here. Here I will write my directly S2 here, that is 36, and so I will remove this calculation. So so directly here I will write my S3 is 32. So here 32. Now these are the values of S1, S2, S3. Now so this is S1, this is S2 and this is my S3. Now just put the value of S1, S2, S3 in this equation 1. So here, so from here the characteristic equation becomes lambda cube minus S1 is 12 lambda square plus S2, that is S2 is 36 plus 36 lambda minus S3. S3 means minus 32 which is equal to 0. So here how to find the root of this equation? Here so first try. So find the possible rational root of this equation. So how to find the possible root of this equation? Divisors of this leading element. So divisors of leading element and divisors of here constant. That is here this is your leading element. highest power lambda 3. Coefficient of the highest power is the leading element, and this is my constant. Here the possible rational root for any such kind of equation, divisors of your leading element is 1, divisors of 32. So here divisors of 1 are plus minus 1, and divisors of 32 are here plus minus 1, plus minus 2, plus minus I think 8, so and so on. You can check. So here you can check here. I check already. So 2 is the one root. Here if 2 is the root, 2 is the one root, that is 8 minus 12 into 4. So this 8 here 12 into 4 plus 36 into 2 minus 32, which is equal to 0 or not. I will check here. So which is equal to 0, I will write. Left hand side equal to right hand side or not. Here 8 minus 48 plus 72 minus 32. Here this is plus 78 plus 72 plus 8. This is 80 minus, you can check, this is 80. So this is 0. So left hand side equal to right hand side, that is 0 equal to 0. So 2 is the one root. Now if 2 is the one root, so you can find the other root by using synthetic division. So no need to use this. So here if 2 is the one root, you can find the other root by using synthetic division. 1, write 1 minus 12, this is 36, and this is minus 32. Write this 1 as it is here. Write this 1 here 1. Multiply this 1 to this 2. So write this 2. After that add this 2. So minus 12 plus 2. This is minus 10. Then multiply this minus 10 to this. So this is minus 20. So add this plus 36 minus 20. Minus 20, that is 16. Again multiply this 60 to this 2. You will get here 32. So add this minus 32 plus 33, that is 0. Now here this is my lambda minus a. This is first root right here, lambda minus a, which is corresponding to this root. Now from here, so from here to here, so here constant lambda, coefficient of lambda, and this is coefficient of lambda square. So here lambda square minus 10 lambda plus 16, which is equal to 0. So from here lambda minus 2. So here find the root. Find the root 8 and 2. So 8 and 2 are the factor, and you will get product and summation, that is lambda square minus 8 lambda minus 2 lambda plus 16, which is equal to 0. So you can check lambda minus 2 here. Here I will take lambda as common. So from here these two pair, lambda into lambda minus here, that is lambda minus 8. So from here I will take minus 2 as common. So that is lambda minus 8, which is equal to 0. So here lambda minus 2 as it is. This is lambda minus 8, and this is lambda minus 2, which is equal to 0. Therefore lambda equal to 2, 8. These are the root of this equation. Therefore these are the lambda equal to 2, 8 are the eigenvalues of my matrix A. Now I will find the eigenvector corresponding to, I will try to find eigenvector corresponding to each eigenvalue, lambda 1, lambda 2, lambda 3. So here I will write the eigenvalues lambda 1, lambda 2, lambda 3. So I don't have space. Please pause and write here. So I want to find the eigenvector corresponding to the each eigenvalue. So I think in so you all of you know. So here A is a matrix. Here result, if A is a matrix of order n and you have n distinct eigenvalue. Let's say here you have n distinct eigenvalue, lambda 1, lambda 2. Sorry, here lambda 1 is not same as lambda 2, is not same as lambda 3, and so on, which is not same as lambda n. If you have a matrix A of order n and you have distinct eigenvalue, that matrix is diagonalizable. But here this is the matrix with here repeated eigenvalue. But this matrix is so this is the one result. So here, and second matrix, if A is a matrix of order n, is diagonalizable if and only if this A has n linearly independent eigenvector. So here this is the matrix A is of order 3. So now I have to check whether this matrix A has 3 linearly independent eigenvector or not. If it is, if this matrix has 3 linearly independent eigenvector, then this matrix is diagonalizable. That's I want to check here. So first we find, the first step is over. Find the eigenvalues of this matrix. That is here. Here first step, lambda 1. Here lambda 1 equal to 2 and lambda 2 equal to. So I will write here these are the repeated roots, so that's why I will write first lambda 1 is 8, and you can write no issue, lambda 2 equal to 2 and lambda 3 equal to, let's say, 2. These are the eigenvalues. So here first, now I want to find the eigenvector corresponding to first 8. So after that I will find eigenvector corresponding to 2. So here for lambda equal to 8, so this is the one eigenvalue. For lambda equal to 8, solve a minus lambda I into x, which is equal to 0, here which is equal to a minus lambda is 8 into I into x, which is equal to 0. Therefore write the a minus 8 I matrix. Here I will write here 6 minus 8, that is minus 2. So write all the non-diagonal entries as it is. Here minus 2, here 2, and here this is minus 2, here 3 minus 8, that is minus 5, and here minus 1 as it is. Here this is 2, this is minus 1, here 3 minus 8, that is again minus 5. Here 6 minus 8 minus 2, 3 minus 8 minus 5, 3 minus 8 minus 5, minus 2 2, and minus 2 minus 1 and 2, here 2 and minus 1 as it is. And here x is the column vector, that is x1, x2, x3, which is equal to, here write 0 0 0. So here I want to find the eigenvector corresponding to, so this eigenvalue lambda equal to 8. So here try to convert this matrix into the echelon form, for just for your easy calculation purpose. Here I want to convert this matrix into the echelon form. First I will do, so first I will add these two rows. So here convert this matrix into the echelon form. Write one sentence: convert the coefficient matrix, that is this matrix, the matrix into echelon form. So here I will write the same matrix here. So minus 2, 2. So here minus 2, minus 5, minus 1, 2, minus 1, that is minus 5. So here how to convert this matrix into the echelon form, that is I will convert into the reduced low row echelon form for our calculation purpose, or you can convert it into the echelon form, that is both are correct. Here I want to add, so just add, first make this element as 1. So here I want to make this element as 1, just divide throughout the row 1 by minus 1 by 2. Here divide minus 1 by 2 to the entire row R1. So here I got the matrix, that is 1 1, that is minus 1. So here this is minus 2, minus 5, and this is 1 minus 1. So here 2 minus 1, and this is minus 5. Now add this here, add R2 changes to R2 plus 2 times R1. So minus 2 plus 2 gets 0. Here R3 changes to R3 minus 2 times R1. Here I want to make this minus 2 at 0. Here R2 minus 2 plus 2 times R1 0. I want to make this 2 also at 0. 2 minus, that is 2 minus 2 times R1, that is 0. So here write one more times, 1 1 minus 1. Again here minus 2 plus 2 0. Here minus 5 plus 2 minus 3. So minus 1, this is minus 2, this is minus 3. Now here 2 minus 2 times 1, this is 0. Minus 1 minus 2 times 1, this is minus 3. Here minus 5 minus plus 2, this is minus 3. Now I want to convert, so first I will divide this row to bar. Here I will divide this row to bar. Whenever you want to convert into echelon form, try to make this first position as 1. So here after making this position as 1, try to make all the elements in the same column to that 1. Here 0. So here I make 0. Now come to this second element, first non-zero entry from left of the row R1. Come to here, try to make this element as 1. So here I am dividing minus 1 by 3 to the entire row R2. Here I got the matrix as 1 1 minus 1. This is 0 1 1, and this is, so you can divide, so no issue. So you can divide minus 1 by 3 to the entire row R3 also, minus 1 by 3 into R3. So here 0 1 1. So here I want to convert this one element into 0. Here I am applying the elementary operation. R3 changes to R3 minus R2. So here I got the matrix as 1 1 minus 1. This is 0, 1, 1. Here 0 minus 0, 0, 1 minus 1, 0, 1 minus 1, 0. Now this is this matrix into the echelon form, and this matrix is similar to this matrix. Now rank of this matrix is 2. Therefore just write this matrix in place of this, and again by using back substitution solve. Here therefore here I will write 1, 1, minus 1, 0, 1, 1, 0, 0, 0 into here. This is x1, x2, x3, which is equal to again 0, 0, 0. So from here you can answer one thing. Rank of this matrix is 2 and number of unknowns are 3. So here corresponding to x1 I have pivot in my first column, corresponding to x2 I have pivot in my second column, but corresponding to x3 I don't have pivot in my third column. Here in row 3 don't have pivot. So here therefore just by back substitution here solve. Therefore x1 plus x2 minus x3, which is equal to 0. So from here second row x2 plus x3, which is equal to 0. Here I am assign x3 as t. Why? Corresponding to x3 I don't have pivot in my third column. Therefore so here put the value of x3 equal to t and x2 equal to minus t in here. So therefore x1 I will write first. I will write x1. This is equal to minus x2 plus and x3. So here from here I will write. So here x1 equal to x2 and x3. This time I will take right hand side. So this is equal to here minus into x2 is here, this is minus t plus x3 is t. So which is equal to minus t plus t plus t, which is equal to 2 times t. Therefore here the eigenvector, that is x1, x2 and x3, which is equal to here x1 is 2t, my x2 is minus t, x3 is simply t. So which is equal to, here I will take t common, t here I am taking 2 minus 1 1. So which is equal to t times, let's say x1. So for sake of argument, let's say this is the eigenvector, this is eigenvector, here this is eigenvector corresponding to lambda equal to 8 eigenvalue. Now I want to find the eigenvector corresponding to the eigenvalue this 2. So here this is one eigenvector, so I will write this eigenvector over here. So here so please pause and write. So I will write this eigenvector. So here for 8, here for lambda equal to 8, so this is my eigenvector. Let's say x1 equal to, here I am writing here 2 minus 1 and 1. So for lambda equal to 8. So here I will write, and now I want to find for lambda equal to 2. So here how to find? Now for lambda equal to 2, so I want to find the eigenvector corresponding to this eigenvalue lambda equal to 2. So here solve a minus, here I will directly write a minus lambda I, that is a minus 2i into x, which is equal to 0. So write the a minus 2i matrix here, 6 minus 2, that is 4, minus 2, and this is 2 as it is, here minus 2 as it is, here 3 minus 2 1, here minus 1 as it is, here 2 and minus 1 as it is, here 3 minus 2, that is 1. Here write x1, x2 and x3, which is equal to here 0, 0, 0. Now here I want to convert this matrix into the echelon form. So here write, I want to convert this matrix into the echelon form. First make this element 0. Here I will apply the elementary operation. First I will here divide. So I will add this 2 row. Here R3 changes to, here R3 changes to R3 plus R2. Here I am applying the operation. So here R3 changes to 2. This is 0. 2 plus 2 minus 2 becomes 0. So here I am applying 4 minus 2 and 2. Here this is minus 2 1 minus 1. So here do one thing. So always try to make at this position 1. So here so follow the proper step, then you will get correct answer. Here I am dividing 1 by 4 to the entire row R1. So here I am getting matrix as here 1. So this is 1, this is minus 1 by 2 and this is 1 by 2 here. So divide, no need to change here, just write here minus 2 1 minus 1 here 2 minus 1 1. So here after making this element as 1, try to make this 2 element 0. So here, so you will get operation as here R2 changes to R2 plus 2 times R1. This is my first operation. Here R3 changes to R3 minus 2 times R1. Here I get the resultant matrix as here 1 this is 1 minus 1 by 2 and this is 1 by 2 as it is. Now write here minus 2 plus 2 times this is 0. Now here this is 1 plus 2 times this is here 1 plus 2 times this is minus 1 by 2. So here this is 1 minus 1, this is 0 here. Now this is minus 1 plus 2 times 1 by 2. So 2 gets cancelled, minus 1 plus 1 0. So this is also 0. Now here 2 minus 2 times 1, this is 0. Here minus 1 here for second row. So calculate properly. Here this is minus 1 minus 1 minus minus plus. This is minus minus plus 2 times here 1 by 2. So this is also 0. 2 gets cancelled, minus 1 plus 1 0. So this is 0. So now calculate this. Here 1 minus 1 minus 2 times here again 1 by 2. So this is gets cancelled, 1 by 0. Now now check. So this matrix into the equivalent form. Here 0 row at below the non-zero row, and this is the leading element. Now this matrix into the equivalent form, and rank of this matrix is 1, and this matrix is equivalent to this matrix. So just write in place of this matrix. Here I will write again. Here 1 minus 1 by 2, 1 by 2. So here 0 0 0 0 0 0 and into here x1 x2 and x3, which is equal to here 0 0 0. Now here you can observe one thing. Rank of this matrix is 1. Number of unknowns are 3, x1 x2 x3, that is x1 x2 x3. So we have to assign 2 parameter as a 3 parameter to either x1 x2 or x3. But here corresponding to x1 I have leading element or pivot in my first column, but corresponding to x2 and x3 I don't have pivot in my second row, second column and third column. So that's why here I am assigning after that first write. So by back substitution, that is x1 minus here x2 by 2 plus x3 by 2, which is equal to 0. Here assigning, so assign x2 equal to, let's say, t2. Here I am just for corresponding to x2, that's why here I am taking t2, and x3 equal to, let's say, t3. You can take t1 t2 also, but here just for easy sake of understanding, here I am taking t2 corresponding to x2 and t3 corresponding to x3. So you can take anything. So therefore x1, which is equal to, take this right hand side, x2 by this is 2 minus x3 by, let's say, 2, which is equal to my x3 is my x2 is t2 divided by 2 minus x3 is t3 divided by 2. So this is my x1. Therefore write here eigenvector. Therefore here x1 x2 and x3 as here, which is equal to x1 is my here x1 is my t2 divided by 2 minus t3 divided by 2, and x2 here my x2 is this is t2, here I will write t2, and x3 is my t3, here I will write t3. So here pi I am writing here and here. So here corresponding to x1 t2 by 2 minus t3 by 2, and corresponding to x2 just have t2, here I am writing 0 times t3. So here x2, here I am writing x2 as here x3 is just t3, so here I am writing 0 times t2. So which is equal to, here I will write column wise. Therefore x1 x2 x3 which is equal to here, which is equal to here I will write t 2 by 2, t2 and 0 here, plus here I am writing minus t here, minus t3 by this is 2, here this is t3 0 and here this is t3. So here I will write t 2 times here, t2 times here 1 by 2 1 0 and plus t 3 times here I am writing minus 1 by 2 0 and 1. So here let's say here I am writing t2 times let's say x2 plus t3 times let's say x3. So here I am assuming this is the eigenvector x2 and this is the eigenvector x3 corresponding to the eigenvalue lambda 2. So here lambda 2 here lambda 2 and lambda 3 same eigenvalue. That's why here I got this eigenvector, this 2 eigenvector corresponding to this 2 eigenvalue lambda 2 equal to 2. So here you can observe one thing in the result, you know. So if a matrix A, that is real symmetric matrix, and this matrix has eigenvalue, let's say this is any matrix here, let's say here this is any matrix, let's say here I am taking matrix A of order 2 and here I have two eigenvalue lambda 1 and lambda 2 and these two eigenvalues are distinct and corresponding to, let's say for example here I am saying for 2 and corresponding to this eigenvalue, let's say this is x1 and this is x2 is the eigenvector. Then this x1 and x2 eigenvectors are mutually orthogonal, means they are orthogonal means here their product, that is x1 x2 transpose is equal to 0. So, or you can take x2 transpose, that we can take x1 transpose x2 equal to 0, either this equal to 0 or x2 or you can write here x1 transpose x2 equal to 0. So anything is 0. So here you have to either show this or this. But here our matrix is of order 3 cross 3. So here we will get 3 eigenvalue lambda 3 here. So you will get 3 eigenvalue. So now, but here corresponding to this real symmetric matrix, we have to show whether the eigenvectors are mutually orthogonal or not. Here, since you can observe one thing, this x2 and x3 are not mutually orthogonal. Why here? Let's say this is my x2. Here I am taking this is my x2 and this is my x3. So you can take x2 transpose into x3, which is equal to 0 or not. Here check whether this is equal to 0 or not. But here x2 transpose is, that is 1 by 2 1 and this is 0, and x3 that is here minus 1 by 2 0 and 1. So here this is not equal to 0. Why? Here which is equal to here minus 1 by 4. So this is 0 0, which is not equal to 0. Since x2 and x3 are not mutually orthogonal, so that's why we have to choose one eigenvector, let's say x3. So here keep this as it is. So you have to check corresponding to this. Here let choose x3 here, let's say here n such that this x3 is mutually orthogonal to this x2 and this x1. That is, here I want to show this x1 x2 transpose is 0 or x2 x3 transpose, sorry, x1 x3 transpose is 0, x2 x3 transpose is 0. So we have to check this. So with this everything will be get. Now here since here write one statement here, since x2 and x3 are not mutually orthogonal, as x2 x3 transpose are not 0. That is here x2 transpose, that is here 1 by 2 1 0 and here minus 1 by 2 here 0 1, which is equal to minus 1 by 4, which is not equal to 0. Here that's why these two vectors are not mutually orthogonal. Then so try to find the eigenvector x3 which is mutually orthogonal to this x1 and this x1 and this x2. Here I will write here I will take let x3 which is equal to here n such that x1 x3 transpose equal to 0 and x2 x3 transpose which is equal to 0. I want to take x1, or we can take so here for easy calculation purpose both are correct. Here I will write x1 transpose x3 equal to 0 and x2 transpose x3 which is equal to 0. You can take anything. So here therefore x1 transpose is here, this is my x1. Here x1 transpose is 2 minus 1 and x3, that is here write n which is equal to 0. So here 0 matrix of order 2 cross 2. Let's see. And here just write 0 for now. So after that you can write here in the matrix form. Here x2 transpose, that is here I will write, here I will take x2, this is 1 by 2, here this is 1 and this is 0 which is equal to here, which is n which is equal to 0. Now you can solve this. Here this is equal to here 2l minus m plus n which is equal to 0. So from here l by 2 plus m plus 0 times n which is equal to 0. Now write the matrix corresponding to this equation. So you can do one thing. So again we have to convert this matrix into the echelon form. That is the one way. But here we can add this. So you can add or do one thing. So it is better to convert this matrix again into the echelon form. So here I will write how to convert. So the matrix form of this equation is, here I will write here 2 minus 1 here this is 1 by 2 1 0 and here therefore l m which is equal to here 0 0. Here this is matrix of order 2 row 3 column, and this is 3 row and 1 column. So here resultant matrix is 2 row and 1 column. Therefore that is valid. Now here try to convert this into first try to convert this 2 into 1. Here I will divide my entire row R1 by 1 by 2 to the R1. So here after that I will get this is 1 minus 1 by 2 and this is 1 by 2. Here this is 1 by 2 and this is 1 and 0. Now again I want to make this 1 by 2 as 0. Here R2 changes to R2. 2 times R2 minus R1. So this 1 minus 1 becomes 0. So from here 1 minus 1 by 2, 1 by 2. So from here 1, here 2 times R1, 2 times R2 minus, that is minus this is plus 1 by 2. So this is 5 by 2. So this is 5 by 2. Here this is 0 minus 1 by 2, that is minus 1 by 2. Now I want to convert this 5 by 2 into 1. So here divide this is 0 now. This is 0. So here multiply row R2 by 2 by 5 times row R2. So here you will get matrix as 1 minus 1 by 2, 1 by 2. So this is 0. This is 2 by 5, 5 by 2 into 1. So here minus 1 by 2 into here 2 by 5. So here this is minus 1 by 5. This is minus 1 by 5. So this is equal to, now this matrix into the echelon form, rank of this matrix is 2 and number of unknowns are 3. So here therefore again write matrix by back substitution n minus m by 2 plus n by 2 which is equal to 0. Here from here m minus n by 5 which is equal to 0. Here corresponding to L I have pivot, corresponding to m I have pivot, corresponding to n I don't have pivot. That's why assign n equal to t. Therefore m equal to here n by 5 which is equal to t by 5. Therefore from here n equal to m by 2 minus n by 2 which is equal to m is t by 5. Here this is 10 minus n is t by 2. So here this is 2. So from here you will get so do one thing, here 5 minus 4t divided by 10 which is equal to minus 2t divided by 5. This is my L. So this is my L. So here now write again. So I hope all of you written this. So I want to, here I will write here. So this is equal to, therefore L m L, here my L is minus 2t by 5, my m is t by 5, my n is t. So which is equal to, here I am writing t as common, here minus 2 by 5, 1 by 5, 1. So here multiply 5, so you will get minus 2, 1, and this is 5. Here this is the x3. Now you can check, this is my x3 which is mutually perpendicular to x1, x2, x3. Now here this is my x1. Now right here I will write x2 equal to, here I am taking x2 as I think, where is my x2? Here is my x2 is this one. So here 1 by 2, 1 by 2, 1, 0, and here just now I found my x3 which is equal to, here minus 2, 1 and 5. Now you can check x1, x2 transpose is 0. Now this x1, x2, x3 are mutually perpendicular. Now you can check this three vector x1, x2, x3 are orthogonal and independent. Now we have to check this x1, x2, x3 are normalized or not here, but you can check the length of x1 is here 4 plus 1 plus 1 root 6, that is not 1. So first you have to convert the length of x1, length of x2 and length of x3 as 1. So in the model matrix P, the element of model matrix P is the eigenvector corresponding to the eigenvector which is normalized eigenvector as its column. So that is the here model matrix P. So now first find the length of x1, x2 and x3. So here since model matrix P have eigenvector, that is normalize eigenvector as its column. So here therefore length of x1, here length of x1 which is equal to norm of x1 which is equal to, find the norm of x1 is, here length of x1 is, here I will find here 2 square, that is 2 square plus minus 1 square plus 1 square which is equal to, here 4 plus 1 plus 1, that is root 6. Here length of x2 which is equal to norm of x2 which is equal to, here so length of x2 is which is equal to, here 1 by 4 plus 1 plus 0 which is equal to, here root 5 by this is 2. So here now length of x3 which is equal to norm of x3 which is equal to, here mod of 2 square plus 1 square plus 5 square which is equal to 4 plus 1, here 4 plus 1 plus 25 which is equal to root 30. So here this is my length of x1, x2, x3. I want to convert this x1, x2, x3 which is normalized. Just divide the vector x1 by length of x1. So resultant vector x1 dash, you will get vector with length of x1 dash is 1. So here therefore x1 dash which is equal to x1 divided by norm of x1 which is equal to here 2 by root 6 here minus 1 by root 6 which is 1 by root 6. So this is my x1 dash. You can check length of this x1 dash is 1, that is normalized. Now x2 dash which is equal to x2 divided by norm of x2 which is equal to here x2 dash, that is 1 by 2, this is 5 by root 2, this is 1 by root 5, this is 2 by 1 by so you can check here 1 by 2 by root 5, this is 0 here, and x3 dash which is equal to x3 divided by norm of x3 which is equal to here minus 2 by root 30 here 1 by root 30 and 5 by root 30. So here this is the eigenvector x1 dash, x2 dash, x3 which is normalized, and you can check mutually orthogonal. And here I will write the matrix P. Here first column is my first eigenvector 2 by root 6 minus 1 by root 6 1 by root 6. Second column is my second eigenvector, that is x2 dash 1 by root 5 2 by root 5 and 0. Third eigenvector is my third column minus 2 by root 30 here 1 by root 30 and 5 by root 30. So this is the matrix P, so which is the model matrix. Now since diagonal matrix is orthogonally similar, since this P is the orthogonal matrix, you can check P into P transpose is equal to I. So here write one sentence just, since P is orthogonal, therefore P into P transpose is equal to I. This implies P into here P transpose is same as P inverse. So this implies P transpose is as P inverse. Therefore model matrix, therefore the diagonal matrix D equal to P inverse AP, which is same as P transpose is P inverse is same as P transpose A. This is P. Therefore D equal to P transpose AP. So here just write now. So P transpose matrix is here. I will find P transpose equal to here. This is my P. P transpose is 2 by root 6 here 1 by root 5 and minus 2 by root 30. First row becomes first column. Here second row becomes second column. Minus 1 by root 6 here 2 by root 5. This is 1 by root 30. Here second row becomes second column. Here third row third column. Here 1 by root 6 0 and 5 by root 30. So this is my P transpose matrix. So here now write D equal to P transpose AP. Here I will write. So you will get the D matrix here. So I will write D equal to, that is P transpose A P matrix. So here P transpose is, write this matrix here 2 by root 6 1 by root 5 and minus 2 by root 30. So here minus 1 by root 6, this is 2 by root 5 and this is 1 by root 30. Here 1 by root 6, this is 0, this is 5 by root 30. This is P transpose. Now write here A. 6 minus 2, 2. Minus 2, here minus 2, here 3 minus 1. So this is minus 2. Here 2 minus 1, 3. Now write P matrix. So P matrix is here. P matrix is available here. So I think the value of P matrix is here. This is P transpose, means you can take transpose of P. So you will get here. This is P transpose. Take transpose of again P. So if transpose of this. So transpose of P transpose, you will get P. So here first row first column, that is 2 by root 6 here minus 1 by P is 6. This is 1 by root 6 here 1 by root 5 here 2 by root 5, this is 0, and minus 2 by 30, here 1 by 30, and here 5 by root 30. This is my P matrix here. Therefore, just we can calculate all this matrix. You will get the diagonal matrix having here you will get the matrix 8 0 0 0 2 0 0 0 2. So here this is the answer. Find the diagonal matrix orthogonally similar to A. Means this is our D. Therefore, this is the matrix D. Here, this is the diagonal matrix D, which is orthogonally similar to our real matrix A. That is our answer. So here, in this way, you can calculate a diagonal matrix D, which is orthogonally similar to this matrix A for repeated root also. So here, if you have distinct root, so lambda 1, lambda 2, lambda 3 are distinct. So you can calculate easily, but sometimes you will get the repeated root. At that time, you have to do some more calculation. So here, this is the way to calculate the diagonal matrix D, which is orthogonally similar to A. So here, I will again explain the working rule for diagonalization of square matrix. First, find the eigenvalue of the given matrix. Second, find the eigenvector corresponding to each eigenvalue. Third, build the model matrix P, which is build the model matrix P having normalized the eigenvector. They are mutually orthogonal also. And fourth is D equal to P transpose AP. Whether check orthogonally similar or not, or orthogonally similar to the real symmetric matrix or not. So you can write D equal to P transpose AP. So here D equal to P transpose AP. You can just calculate. Here you will get the diagonal matrix D having all the non-diagonal entities are 0, because this is the diagonal matrix, and the diagonal entities of this matrix are the eigenvalues of your given matrix A. So in this way you can solve the any matrix that is having repeated root, and so you can solve like this and you will get the answer. Thank you.